Hi, I'm Jadi and welcome back to our LPIC 1 series. We recently finished the exam 101 and now starting the exam 102. These two combined will give you LPIC 1. But the good news is 102 is much simpler than 101. I was thinking maybe they are the same, but I believe 101 is more difficult because there we are speaking about modules, how to boot the Linux, how to control subsystems and this kind of stuff, how to partition. But here we are talking about a more general concept that system admins will use daily. So let's start 101 with the 105.1 customize and use shell environment. In this section, in general in 105, which is part of the 102 ugly naming, we are speaking about the shell scripts. When I'm telling shell, I'm speaking about this environment. We will see a little bit more detailed info later. But generally, shell is where you write your commands, get the answers back. Okay, we'll speak about this in the next section. But the general shell in LPIC is the bash shell, born again shell. We used to have a very simple sh shell, then bash shell, then zsh, csh, ksh, lots of different shells. But what we are speaking about is bash in LPIC, and most of the concepts are the same. You will use the same concept in ZSH, CSH, or KSH, more and less. But our focus will be on bash. If you are using a Mac computer, ZSH is your default. Also on some distros like Kali uses a fancy ZSH configuration. But the general things are the same. On the first part, on the 105.1, I will have A and B parts here. But on this one, we are speaking about customizing and using the shell. On the next one, 105.2, I will speak about the basics of the shell scripting. The point is, when you are doing shell scripting on the LPIC level, LPIC 1 level, you don't need advanced things. You should be able to study a shell script, change it, or write simple ones. Anyway, let's start. And the weight is 4. It's very important. You should know lots of things. I will cover in 2 sections. But first, let's see what is a environment variable. You have this shell running, right? And you know what is a variable. In programming language, a variable is a method to define something equal to something. You have a name equal to a value. For example, you can say my name equals Jadi. And later you can use the name. For example, check if the name is Jadi. Or say echo name. This will print the name. I want to check the name variable. So on bash, I have to do like this. $name. This will echo Jadi. Let's see it. So very basically, variables are like this. It's a convention to use uppercase letters for your variables. You can use A to Z, capital letters, also all the numbers, and underscore. For sure, and in many programming languages, your variable cannot start with a number. So name is a valid variable, underscore name is a valid variable, but name is not. And it's a convention that it's better to use uppercase letters. So I can say name equals Jadi. Echo $name. Please pay specific attention. Bash is written to be small and very portable. So they haven't implemented, for example, you cannot say name space equals Jadi. Bash won't understand this. Bash just checks for equal sign, checks here for the name, checks here for the value. So no spaces. So when defining, you don't need the dollar sign, but when using to tell echo that you are showing a variable here, you should use the dollar sign name. So I can say full name equals Jadimir. Can we do this? No, because shell will try to say, okay, full name equals Jadi, now run mir, and no command mir found. So you have to say, so again for shell, it's a variable name here, equal sign with no spaces, and one thing here. You could use single quotes or double quotes, no difference for the shell. So I also have full name. I can say echo, my name is dollar full name, and show it. My name is Jadimir. You have two commands to show the variables. One is env. This will show you the system variables only. For example, user is Jadi. You see, I have lots of variables to let the shell run as intended. For example, if I go to my home, shell knows that my home is this. If a program wants to print something in my local language, it would check this lang and say, okay, English US UTF-8. So write it like this. Env will show you the system variables. But we have a more common command, which is set. Set will show user-defined variables, defined functions, we will see them later, and these kind of stuff. So set will give you a much longer output. I can pipe it to less and show you some of them. For example, it says bash is running from here. Bash is running, okay, 59 columns is the width of this thing. So if something wants to print something, may check this one. Bash version is this version. Full name is Jadimir. This is what I defined recently. It says history file is this. So if bash wants to save something in a history file, then you can go and see it using the up arrow or Control R for searching. It will be written here. History file size is 2000 commands. Cool. 2000 for the history file size. This is the history size is 1000. This is my home, my host name, and lots of other information. If I scroll down, you will see more configuration. My login name, my OS type is Linux. My PWD, my home directory is home Jadi. This is my shell. I'm connecting from a SSH client from this ID. Let's go down. Larger things here. And there are some functions. You will see them later. So all of these can be checked with the command set. Also, set can do some other things. For example, set-b will cause the status of terminated background jobs to be shown immediately. If you remember, we used to run things in background. When they were finished, on the next command, it would show me that, okay, this is finished. If you do set-b, it will show the output immediately as soon as it happens, and some other configurations. But for us, env, which is a specific type of printf. Env is a more general command. Then we have env, which does the same thing, but shows only the system-specific configurations. The set will show all the environment variables, and you saw how we can set them. Okay, say I create an environment variable called name. We just did. I can create another one for my friend, which is, for example, Sarah. Ow, I said echo friend Sarah, and friends is nothing, so it didn't work. I say, because here you can see that $friend is not defined, so nothing will be printed here. It will just write this part. But here I created a new variable called Sarah. Say I want to unset this. I can say echo friend friend will show my friend. Okay, I can say friend equals to nothing. Then I can say echo friend. But the problem is that friend is defined, but it is nothing. I can set grep the line with this. So it's okay, friend is defined, but it equals to nothing. If I want to unset it, I have to use the unset command. Unset name. Now if I say echo name, it is nothing. If I say set grep the name, it says okay, no name is there. I have a full name, I have a host name, I have a log name, I have name in some of my functions, but no variable name is set. Also, this is good to show you that name can be Jadi, name can be Z. Here, if I echo $name, that would be Jadi, echo $name, that would be Z. So capital and small letters are different. This is case sensitive as any sane system. Okay, so now you know how to set and you know how to unset. Let's talk about export. Pay attention. This is a little bit more complicated and super fun to know. Now I'm in a bash process, right? A bash is running. Whenever you run something here, for example, a ping command, this is how Unix systems work, so how Linux works. It initiates a new subsystem, child, or fork. Inside that, it will run the ping. Then, when ping is finished, that subsystem will return back to the current bash. So I have another shell here, which is running my command. This is called forking in Linux. Bash will fork itself, will run the ping, and will return back. So what is the case here? I have defined my variable as echo $name, as name here. So I'm in a bash shell, and I added a variable name here. If I run any other command here, for example ping, a subprocess, a child, will be run here inside another bash, and ping is running here. This doesn't see this variable. This is the case. So if I run another bash, that bash won't have this variable. If you configure, for example, a proxy using a HTTP proxy variable, and your program understands this proxy and run that one, that won't be able to use this because this is defined in this bash and not in the subprocess. To let the subprocess have this configuration, you have to use the keyword export. Let me demonstrate it to you. Let me define a new variable. That would be, for example, my name is Jadi. Now I start a bash. So I had a bash here, was running, defined my variable here, initiated a new bash, which is running as a sub-process or fork. This doesn't have access to this. Let's check my claim. Echo $my name. It's not here. So if I exit, now I exited this specific bash I ran, so I'm back in this bash. And if I echo $my name, it's here because I'm in the main bash. If I wanted to have this configuration in every other sub-process I initiate from here, I spawn from here, or I fork from here. Any command you run will fork a bash, that bash will run this. If I wanted my specific variable there too, I had to export it. So I had to say export, for example, just to check, new name is Sarah. And then run a bash. And then echo $new name. And Sarah is still there. So, and I'm inside this bash now. If I wanted to exit, I would exit, and I'm in the main bash. What I did was I had a bash, I defined a variable here, I ran any command which will be running inside a sub process, and this variable was not accessible there. So if I wanted to make it accessible, I had to say export my variable. When I exported it, it was accessible in the commands I was running inside this bash. For example, I ran another bash to show you that I have access to that one. So this is what export does. We had the same problem with the source. Say I have a configuration in one script. Say I want to, let's create a file. This is part of the next section, next chapter, but let's have it here for a moment. For example, I have a config sh, and I say my conf is funny config, just a variable defined here. If I want this to be executable, I have to add a shebang line to it. This is called shebang in bash. We will talk about this later in the next chapter, but it's very easy. Just the first line of your script starts with a hashtag or DS, then exclamation mark, then what should run when you run this script. This is called the shebang. So this script will be running using bash. I can say chmod config. So cat config. It defines a new variable myConfig and equals it to funnyConfig. If I run this and they say echo myconf, it's not there. Why? You kind of know this. I was in a bash. I ran a script here. So it initiated a new subprocess, ran it in the shebang line using bash, ran this script, and defined a new variable. Then this is finished and returned back to my process. So the variable is not there anymore because it was running in this specific subprocess. To solve this problem, we have a command which is called source. I can say source config sh. This tells the bash not to initiate a new bash to run this. I was in bash. Normally, if I ran this, it would be a sub-process running it and then returning back when this is done. So no configuration is here anymore. But when you are saying source config, you are telling this batch to run this script without initiating a sub-process, a child process, a forked process. So the configurations sets here, the variables will be available in my main bash, as you can see. What happened? Okay, now I have the echo myconf because I use the source to run this. Because this is being used a lot, it's very common to run a script and need its variables in your bash. We have this shorthand, a simple dot. It's equal to the source. Let's talk about two small things and finish this part and continue in the next part. One is aliases. You can define lots of aliases. If you just say alias, it will show you all your aliases. If you know what the alias mean, you know what it does. Alias, LL equals LSALF. L equals LS-CF. LS equals LS color auto. So you are defining new names for things. So whenever I say LS, practically I'm saying LS color auto. So you have the answers in color. You can define yours. You can say alias, for example, test ping equals ping 4224, for example. So now if I say test ping, it will run this command. It is a very common practice to have some aliases in your bash RC. This is a file which runs whenever you enter the bash. We will talk about this in the next part. But it's very common to define some aliases here. For example, many people will use LL for the long format instead of doing this. In many distros, this is defined. So I now have a new alias. If I say alias, sometimes the switch is -P to print them. Sometimes you can just say alias. I have a new alias which is called test ping, which runs this. So whenever I want to test my connectivity, I can say test ping. You can even say test ping, add more switches. I4. Interval is 4 seconds. Was it longer? Anyway, so I was thinking that sometimes it's very fun to create new aliases. Sometimes it's not. If it's your own system, it's good to have lots of aliases, does fun things, quick access to different commands you always use. But the problem is as soon as you SSH to some server, you sit on another machine, you just type something which is meaningless. So most of the times I myself try to be on the default key bindings, default commands, and these kind of things. And the last thing is the functions. It's like aliases, but a little bit larger with more functionality. For example, you can say, I have a function funny ls with a curly bracket, you define it. I copy this here. As you can see, I say I have a function. This is the beginning and the end. It is called funny ls, and it does this. So you can have larger functions which does lots of things. But if you do a funny ls, it does ls, then echoes this. To finish this part, this section of this chapter, I will describe this in the next part. Just let me show you one fun thing. Echo $SP1. No, PS1. This is how my prompt works. This is your prompt. This is prompting you to give it commands. And this is the configuration, which this says, I want to change the color, blah, blah, then I want this, and I want that. This is a very complicated one. Let me create a small, funny one. PS1 equals hello. So now this is my prompt. You have some shorthands here. You can say hello-user. Sorry, /user or /user. Hello, Jati. Cool. You can say -T for time. It always shows you the time. Or a more common one is $. Or you can say show me the directory I'm in. Now it is like this. Hello was silly. I can use the host name. Like this, for example. Ubuntu servers, Jadi, blah, blah. I used to fiddle with this a lot. Configure mine, create something, and some distros do have very fancy ones. For example, the Kali Linux. You can do a search for PS1 config, for example, and there are lots of sites. Will show you what you can do. Will give you the funny ones, you give you the cool ones, how to change the color, and everything. Jill Smith? What is this? Anyway, the version of the bash. Anyway, let's go to the next section and talk about different shell environments.